I'm going to rewrite as e to negative 3x and minus 3x e to negative 3x. Okay, so now I differentiate to find the second derivative. So e to negative 3x times negative 3 minus 3. Now I have to differentiate x e to negative 3x again, but it's this function. But let's write it again. So the first function prime is 1 plus x e to negative 3x times negative 3. Okay. Negative 3 e to negative 3x. This times this. Minus 3 e to negative 3x. So negative 3 times negative 3 is positive 9. 9x e to negative 3x. Negative 6 e to negative 3x plus 9x e to negative 3x. Okay. So we factor out e to negative 3x and also a 3. So from here I have 3x and from here I have 2. Of course, it had to be a number between 0 and 1/3, right? Okay, so let me just make sure that I have the correct answer. Okay, so then when the second derivative is set equal to 0, we get x equals 2/3, of course. Are you surprised? So 1/3, 2/3, okay. Okay. Now I have to study the sign of the second derivative. This is always positive, so this will be negative, and this will be positive. The function doesn't hold water, and the function holds water. Okay, so of course this is an inflection point. The second derivative is 0, and it changes sign, so this is an inflection point, and this is a relative max. But I have to punch 2/3 in the function because I don't know the y value. Okay, so oops. So I want 2/3. 0.09. Beautiful. Beautiful, I'm saying, because how can I plot something like this? So it's correct, 0.19 down to 0.09 down to 0. Okay, perfect. That's all I need. So now we're ready to graph. Terrible numbers, but we'll make it work. Okay, so I have 0, 0. I have 1/3 whatever this is and 2/3 whatever this is. Okay, I don't even know how to. So if I say that this is 1, I'm going to say that this is 1/3, and I'm going to say that this is 1, and 0.12 I'm going to make it, I don't know, here, and 0.09 I'm going to make it here. Okay. So, and this is a horizontal asymptote. Good. From negative infinity, opening down, increasing to 0. Okay, fine. Continuing up to 1/3, 0.12 for a relative max. Fine. Good. Coming down, still opening down to 2/3 this point. Okay. Perfect. Then here I know it has an inflection point. It has to change concavity, and at this point opens up, getting closer and closer, closer and closer to the horizontal asymptote. It's a very interesting function. It's not a function for a final exam, but it's a very interesting function. Yes, you can punch it in the graphing calculator to double check everything. We already have it. I have to change the viewing window to the standard viewing window. And if somebody copies something like this, I know the person hasn't studied the topic. This is not possible. And it's not possible because the numbers are so small. So now I have to adjust everything to show that relative max, which happens to be an absolute max as well. Okay, so the viewing window, -1 to the maximum, okay. Y minimum, -1, and the maximum 1 with a scale of 0.2 or 0.1. Let's see what happens. Ah, a totally different story. As expected, crosses at the origin, it's coming from -infinity, reaches a maximum, continues down, has an inflection point, which kind of difficult to see with the calculator, and then opens up, approaching the horizontal asymptote. What is the relative max? I know it. It's 1/3, 0.12. So second on calc, I want a maximum, that's number 4. I want the maximum between 0 and 1. Give me the maximum, and it better be 1/3, I mean 0.333. No, I don't want to guess. And 0.12, because we calculated it. We don't need the calculator anymore. We need the calculator to look and make sure we don't have errors. But the calculator on these problems is redundant now because we know calculus. It was a very interesting problem, not for a final exam though. Good. Next topic. Any questions on any of this? Any questions? Okay. Next topic, next question.
Chapter 5, Consumer Surplus.
Okay. Any particular problem?
No.
Okay. And that is 5.1 and page number is 480. We had also a problem last time. I don't remember. I do remember actually. It was I think it was 16. We went through all 16. Anyone?
Can
Okay.
we do question 15?
Yes. Okay. Good. Let's look at 15. And that's on 480. And we did this in class, I'm pretty sure, when we studied it, I think. Anyway, it doesn't matter. 7.5x squared minus 60.5x and plus 254. And we're also given the supply function as 15x plus 95. Okay, so she's interested in 2 jumps, and we want the consumer surplus and the producer surplus for 2 jumps. Okay. So there are 2 different points. Since this is not the equilibrium point, it's not. So we have 2 and d of 2, and we have 2 and s of 2. We need to determine these points first. So I'm going to put these 2 functions in the graphing calculator. Delete everything else. So the first one is 7.5 x squared, and then minus 60.5 x and plus 254. No. and the supply function 15x plus 95, and I will plug in 2 in both of them, and it's 163. So the first one is 2 163 and the other one is 2 105. Good. So now the consumer surplus will be the integral from 0 to 2 from this function minus this product, 2 multiplied by 163. The producer surplus will be this product, 2 multiplied by 105 minus the integral from 0 to 2 from s of x dx. And since this is just integrating quadratic and linear functions, like we did last time, I like to directly calculate. I meant to do this. Okay. So we have the integral from number 9, so from 0 to 2. And this is from the first function, dx, and minus 2 times 163. And we got $81. And the same thing, 2 times 105 minus the integral from 0 to 2 from the other function, and dx, and the producer surplus is negative 10. Unless I entered something incorrectly, let me double check. 15x plus 95, no, I did not. 7.5 minus 60x, yep, no, everything okay. Good. And now it says find the equilibrium point and then recalculate the consumer surplus and the producer surplus at the equilibrium point. In order to find the equilibrium point, I have to set those two equal to each other. So 7.5 x squared minus 60.5 x plus 254 minus 15x minus 95 equals 0. And I have to combine like terms. Let's see what we have. So 7.5 x squared. These two minus 75.5x and plus, so what do I have in here? 9 from 4, and I think I have this. Correct me if I'm wrong. Yes, I think I'm correct. I'm not going to solve this by hand. I'm going to put it in the graphing calculator. So go to apps, and then 9, and it's polynomial. S is degree 2. The first coefficient is 7.5. The second coefficient is negative 75.5. And did it take it? Yes, it did. Okay, and the last one, 159. And then x equals 3. And x equals 7.1. However, it clearly says no more than 5. So I have to use only 3. So the equilibrium point is 3 comma, and now both of them are the same number at 3, of course. So I will plug in 3. So at 3, both have to be the same, 140. Okay. So therefore, the consumer surplus will be the integral from 0 to 3 from the demand dx minus this product, and the producer surplus is the same product now, the integral from 0 to 3 from the supply function dx. Let's see what we get. So, good. Okay. Okay, I'm gonna fake this one, so to speak. Okay, I'm just overriding. I'm not faking anything. Okay, so this is the producer surplus. 3 times 140 minus the integral from the second function from 0 to 3, and that's it. So now we get 67.5. And now I need the first one. Not this one. Not this one. This one. So it's 3 times 140. So it's the integral from 0 to 3 from the demand function dx minus 3 times 140, and we get 137.25. So the consumer surplus and the producer surplus at the equilibrium point are these. And if she only jumps twice and not the equilibrium point, then these are the consumer surplus and the producer surplus. Good, good point, good question. Good. Next topic. Anything else? Good. What are we doing next?
Can we try some anti-differentiation?
Yes, of course. And that's the beginning of chapter 4. So, chapter 4 starts on page 392. So, anti-differentiation or indefinite integrals is the same thing. You may or may not want to use the integral symbol, but it doesn't matter. The answer is the same. The most general antiderivative, any function, any integral.